Hi, most welcome to Dr. Acharya Academy. Today I am going to discuss the periodic trends with respect to electron gain enthalpy. This topic has been taken from the NCERT Chemistry Class 11 books, which is the part 1, unit number 3. Today's class number is 058. When an electron is added to a neutral gaseous atom to convert it into a negative ion, then the enthalpy change accompanying the process is defined as the electron gain enthalpy. Electron gain enthalpy provides a measure of the ease with which an atom adds an electron to form an ion, represented by this equation that X is the atom in gaseous form. You can add one electron, then the product will be the anion of these X atoms in gaseous. The process of adding an electron to the atom can be either endothermic or exothermic. Endothermic means the reaction is taking energy, and exothermic means reaction is releasing energy. Regarding this endothermic and exothermic, we'll know in details in the chapter thermodynamics chapter. Here you can see that electron gain enthalpy is that how easily this gaseous atom will take this electron, and the electron gain enthalpy is measure of this ease with which the atom adds an electron to form an ion. For many elements, energy is released when an electron is added to the atom, and the electron gain enthalpy is negative. That means when energy is released during the adding of electrons in atom, this is the exothermic because energy is released, and then that electron gain enthalpy is negative. Here you can see that in this table that all for hydrogen it is minus 73. In this group number 1 for lithium minus 60, and here the group 16 oxygen, its electron gain enthalpy is minus 141. For group number 17 first element fluorine, for this electron gain enthalpy is minus 328. But for group number 18 noble gas, its electron gain enthalpy, suppose for helium, you can see the plus 48. Why plus? Because plus means to add the electron in this helium atoms in gaseous form, it needs energy. That means endothermic. And in this case, that's why the electron gain energy is positive. So now we'll discuss in detail about this table. What is the periodicity of this electron gain enthalpy? For example, the group number 17 elements. This is the group number 17 elements. Chlorine, chlorine, bromine. These have high, very high negative electron gain enthalpies. You can see this value is very high compared to the left side, whatever the group number 16 and group number 1 is there. That means it is very easy to add electron in group number 17's elements atom to get its singly charged anode. That's why this value is very high, negative. You have to remember always this electron gain enthalpy, this value is negative, minus 328 for fluorine. It is written there that because they can attain stable noble gas electronic configuration by picking up an electron. Noble gas, I already discussed a little bit. Now I'll discuss in details. Noble gas have large positive electron gain enthalpies because this noble gas atom, by electronic configuration, we know it is the very stable form. And the electron has to enter to the next higher principal quantum level. That means from there, if you add one electron, then it will go next principal quantum number levels. Helium. Helium, what is its stable structure? Electron configuration is the 1s2. So further, if you want to add one electron, then it will be 1s2, 2s1. 2s1 means 2 means the principal quantum number is 2. That means if you want to add electrons for this helium, that electron will go the next higher principal quantum level. So if we add this electron, then these atoms in its anionic form will be very unstable in respect of electronic configuration. That means it is very difficult. You need energy. That means this adding of electrons will be endothermic, and that's why the noble gas has large positive electron gain enthalpies. Electron gain enthalpies have large negative values towards the upper right of the periodic table preceding the noble gas. This is the noble gas. So preceding means you have to come left side and upper right in the periodic table. That means our group number 17 is there. So it has large negative values. And with this value, you have seen that how much large value for the electron gain enthalpies for these elements. The variation in electron gain enthalpies of elements is less systematic than for ionization enthalpies. Ionization enthalpies, when we discussed, we have seen it is so much systematic along the period, along the groups in the periodic table for elements. But for this electron gain enthalpies, this variation is not that much systematic like ionization enthalpies. Ionization enthalpies I already discussed in the previous class, number 57. You can attend that class to get clear knowledge on it. Electron gain enthalpy becomes more negative with increase in the atomic number across the period. If you consider the period, that means this is the second period. So lithium, after that, if you consider that lithium, beryllium, boron, in that respect, group 16 oxygen, group 17 fluorine. So with the increase of atomic numbers across a period, electron gain enthalpy will be more negative. See here, group number 1, lithium, is minus 60. Then with the increase of the atomic number for the group number 16, oxygen, it has more negative electron gain enthalpy, that is minus 41. And with again increasing the atomic number for group 17s and the fluorine atoms, again the electron gain enthalpy is more negative, and the value is the minus 328. The effective nuclear charge increase from left to right across a period. Obviously, because the across a period we know that outermost shell will remain same, but due to the increase of the atomic number, nuclear charge will be increased. So outer electrons will feel more attraction with the nucleus, and that is the reason the effective nuclear charge will be increased from left to right of atoms across a period. And consequently, it will be easier to add an electron to a smaller atom, since the added electron on an average would be closer to the positively charged nucleus. Because nuclear charge will increase, but outermost shell will not increase. So when electron will enter this outer shell's orbitals, then it will feel more attraction towards the positively charged nucleus. So it will be very easier to get the electron gain enthalpies from the left to right of the period in periodic table. You can see also with this value, you see that along the period from left to right, if you go, then this value be increased, and symbol obviously the negative. So negative sign and value increase means it's very easy to add electron in this particular atom. Should also expect electron gain enthalpy to become less negative as you go down a group. This is, you consider the group number 1, so from up to down if you go, then electron gain enthalpy to become less negative, because the size of the atom increases. During the previous class, we understood that down the any group, the atomic size, that means atomic radius, ionic radius, will be increased. Why? Because the new shell is adding from up to down in any group, and that's why entering electron will be away from the nucleus. That means attraction of that incumbent electron will be less. And that is the reason the electron gain enthalpy will be less negative. Along the group, if you go with the elements from top to bottom. And here also you can see for hydrogen it is minus 73. Lithium, it further reduced, that means minus 60, less negative. Sodium, again less negative, minus 53, and so on. Any group, group number 16 also you can see. Electron gain enthalpy of oxygen or fluorine is less negative than that of the succeeding elements. If you consider this for oxygen, so next element is sulfur. So comparative to sulfur, sulfur's electron gain enthalpy is the minus 200, but for oxygen it is less negative. Electron gain enthalpy is minus 141. And for the fluorine also like that, fluorine has less negative electron gain enthalpy, which is minus 328, than chlorine atoms whose electron gain enthalpy is minus 349. Oxygen or fluorine, then it will go in the second quantum level where n is equal to 2. And this shell, where the principal quantum is 2, there the significant repulsion from the other electrons present in this level, because in this case, if one electron, when it will enter, then it will feel the repulsion from other electrons in case when the principal quantum number 2 in that particular shell. But for the sulfur and chlorine, its shell's principal quantum number is 3. So in this case, this shell has larger pace, and when the electron enter in this shell, then it will feel comparatively less electron repulsion. And that is why for the oxygen and fluorine, electron gain enthalpy is comparatively less in both cases compared to the succeeding elements sulfur and chlorine. Now discuss about one problem. Which of the following elements, phosphorus, sulfur, chlorine and fluorine, will have the most negative electron gain enthalpy and which the least negative? We have to explain also, we have to justify the answer. So first, we have to consider electron gain enthalpy generally becomes more negative across a period. Already I discussed from the left to right, if you go, those elements will have more negative electron gain enthalpy. That means more easy for electron to enter this atom in gaseous form to form its anionic form in gaseous state. And within a group, already I discussed that electron gain enthalpy becomes less negative down a group. So adding an electron to the 2p orbitals leads to the greater repulsion than adding an electron to a larger 3p orbital. So these 3 points we have to consider. You see that fluorine, it is the principal quantum number 2, this state. So it will get more electron repulsion, and phosphorus, it is group wise, it is down. So you have to consider these things. And chlorine is in principal quantum number 3, I already discussed. So hence the element with most negative electron gain enthalpy is chlorine. That means for chlorine it is very easy for an electron to enter in its orbitals because electron repulsion is less. With the least negative electron gain enthalpy, it is phosphorus. If you count the phosphorus, then group wise it is below, and that is the reason. If you see the periodic table, then in group it is below or from all of other elements, and that's why the chlorine has more negative electron gain enthalpy and phosphorus has less, that means least negative electron gain enthalpy. I hope that you understand which topic electron gain enthalpy is and its trends in the periodic table. You can go through also the podcast of Dr. Acharya Academy for honors degree chemistry level education. Thank you so much for watching this class.